Hello everybody and welcome to our webinar with FME and Migration Center today. Today we will cover the topic how to migrate your legacy ECM and custom content applications. Before we start, let me do just one slide of housekeeping real quick. Please note that all attendees are muted during the whole session. Questions can be entered into the GoToWebinar, either the questions or the chat panel per default on your right-hand side. I will collect the questions and we will take care of them in a dedicated Q&A session after the main part of this session. Please also note that this webinar is being recorded and we will share it with you after the session once it's processed. Okay, let's move on to our today's speakers, or actually it's just one speaker. It's Jens, our lead from Content Center Migration Services. But let me also mention Antje, our senior consultant from Migration Services, who was responsible for creating the live demo you will be seeing today. Okay, with that, I don't want to keep you waiting. Let me hand over to Jens, who will then start with the slideshow. Have fun.
So, hello everybody. Thanks, Mark. Thanks for introducing. As Mark already mentioned, I'm responsible for the Competence Center Migration Services. We implemented this Competence Center as the migration competency in FMEs distributed horizontally across most of the business units and is one of the core competencies of FME. FME was founded back in 1995 with a focus on all topics in the area of enterprise content management. We have a long-lasting partnership with Documentum and OpenText, as well as other vendors like Alfresco, Microsoft, and recently also Box. Meanwhile, we have about 250 employees, offices in Braunschweig, Munich, Frankfurt, and Düsseldorf, as well as subsidiaries in the US and Romania. From a vertical perspective, we emphasize very much on industrial manufacturing, automotive, energy, and have a focus on the regulated environments of the life science and pharmaceutical industry. But apart from ECM, we also have dedicated teams for consulting around the challenges of digital transformation, cloud enabling, replatforming, with partnerships with Amazon, Pivotal, and others. We have a big focus on the life science industry, FDA compliance, and a special team who is only working in these verticals. And also, for sure, we have a product development department. What's the reason for today's webinar? What's the challenge we are talking about today? Many companies have been developing applications, custom applications, and have been growing a bloated application portfolio for not only 10 years, but really over decades. And at the same time, they've grown up heterogeneous infrastructures where there were built data silos on different platforms. So as you can read here on the slides, that's not something I invented. It's really that 38% of the largest organizations have more than 5 different ECM systems. And for the bad, there's the fact that about 60 of 80% of operational data really is of operational applications is inactive. And that's getting even worse by the fact we have new paradigms like big data, where you keep rather more than less data, increasing regulations, and last but not least, increasing pressure for innovations. So with this, the impact of these bloated application portfolios and data silos is that typical IT budgets are spent by 70% on maintenance only. I want to focus especially on this dot you see here in the middle that is obsolete. And this is really a thing which brings many companies into trouble with their application portfolios, because systems or technologies are running out of support, expert knowledge isn't available anymore, or maybe even data is inaccessible. And so perhaps you may prefer a standard migration approach for these. There are no connectors for your custom application or old legacy system to be migrated to a new platform. Basically, the bridge, speaking in pictures, the bridge is broken. But rather than talking about decommissioning or consolidation initiatives, which definitely is important to consider on one hand, but today I want to give some very practical advice how to tackle the problem to get the data out of the legacy system and into a standard migration approach. So basically rebuilding the bridge. If you're interested in consolidation or decommissioning, have a look at our website. We have done many webinars on these topics, or simply ask us. So I've been speaking about standard approach and standard tools. Most of you may already know or have heard of our standard product migration center, which is not only a tool for migration, but it also brings, which how you can see in the picture there on top, but also brings a proven standard migration approach for content migration. So Migration Center is in the market for more than 12 years now. We have done more than 400 migration projects. It's 100% out of the box, and so on and so forth. And we have more than 140 migration paths, where a migration path is a unique combination of source and target system. But today we are speaking of the case if there's no connector available. That's not a problem, because in many situations, and that's my focus for today, we have done migrations using the database connector. And in fact, it's really a common practice we used for custom applications. For example, the old FileNet repositories, several custom built applications, or Centuri, which is a Swedish case management system, and many more. So using the database connector, if there's no specific connector for your backend system available, is really a common approach. And yeah, today I want to show you how to work with the Migration Center database connector. It's really, you can kill two birds with one stone. First, you can avoid custom coding for extracting content from your legacy ECM, because custom coding is typically, it's either expensive or it's poor quality. Its reusability is very limited, it's inflexible, and in the end it's high risk. But it's not done with extracting the data. You need process to process these data, and you need to inject it to the new target system. And that's basically the second bird we kill. Or to be more positive, the really good thing is we are already in a standard approach when we've used the database connector, because we use the Migration Center approach, which is really proven from, as you've seen, more than 400 migrations. It adds capabilities like the rule-based transformation engine, real-time simulation of your transformations, monitoring and reporting, so basically keeping up transparency throughout your migration, and it supports a broad range of target repositories, as well as a good scalability by setting up multiple, as we call it, job servers at once. You won't get this if you do or plan a custom coding initiative for your data migration. So what is our approach? We say proven approach because it's the same across all projects, all platforms, and it is supported, and it's even enforced by the Product Migration Center. On the first step, and that's what we do with the database connector, we analyze or we scan and extract the data from the source system. And the second step is we organize what we've scanned from the source system and break it down into smaller parts and manageable sets. We call this mix sets or migration sets. And all other steps after we've set up these migration sets will handle these manageable pieces, the migration sets. First step is we can transform what we've read from the source system. We have a very capable rule-based engine which allows quite complex rules without any coding. After we've transformed the metadata, we will validate the results, and with a metadata system or metadata model that's implemented in the target system. And we have the capability of simulating these transformation without any impact on any source or target system. So we can simulate the transformation, validate the transformation, and correct the transformation until we are 100% sure that we will get the expected results. And when we've done this, we start the import to the target system. And in this process, you can run each step independently from each other, or you can run it in parallel. And you can as well scale up the performance of this by, I mentioned it already, by setting up multiple job servers working on your migration process. So now how you see here all the parts of our services portfolio. I won't read into each of them, but now when we find the situation that we have an application that is not supported by a specific scanner or extraction connector, we have the option to develop a new connector. But developing a new connector involves quite some development work on one hand, and on the other hand, it's specific again to a single system. So if you're looking at migrating several applications, it might even be the better thing to use the database connector instead of developing a specific connector for your legacy system. So how we would proceed would be that we start an analysis project on the source system. And once we've analyzed the source system, we would do a proof of concept that working with a database connector will deliver the expected results. And this brings us much closer to the technology, and we'll be getting a bit more technical now. So here on this slide, you see the capabilities of the database connector and how you can set it up and configure it. First prerequisite for using the database connector is that you have a JDBC driver available for your database. The capabilities of the database connector are in bold characters here. But first of all, you need to analyze the database scheme, assuming that you already know what you want to decommission or migrate from the legacy system. You will start with analyzing the database, where to find the respective elements in the database. If it's a homegrown system, a custom-built application, even better, probably you already know the database schema. So if you, at the point in time when you know the database schema and the analysis, I will show this in the demo later on, typically is much more straightforward than you might expect. Once you know this database schema, you will start extracting the content. First step is that you extract all objects from your source system. The respective SQL statements are all defined in an XML file. We call this a query file, where the statements are gathered. So once you've this SQL statement to extract all objects, typically an object is a document, but it also can be a block or whatever, image. Then you want to extract the metadata for the objects. The steps number 3 to 6 on this slide are optional. When you have the objects, typically extract the metadata for the object, but in many cases you will have multiple versions for an object. So instead of extracting the metadata for the document, you first want to extract all versions of a document. And once you have extracted all versions, you want to extract the metadata for the versions. And last but not least, you want to define an SQL statement where you can extract the content for the respective versions. The capability of the database scanner allows you to extract content either from an UNC path, so this would support systems like NetApp, SnapBlock, or an IBM filer or file system. So with this method, you will cover most of the ECM systems currently on the market. The second option for extracting content is that the ECM system or content application will store the content in the database directly. You also have the option supporting this with a database scanner by extracting the content from the blob file or a CLOB. In this case, we also support the extraction of multiple content objects for a single version. So think of a thumbnail, think of multiple renditions. This is also supported. Looking at point 3 and point 5, you see you can define multiple one-to-n statements if you need to gather several, or if you have complex queries for retrieving metadata information for your respective object. So this is also quite a typical case, that it's not only a single table where you can retrieve the metadata from, but often we have even classification trees, so you can retrieve classification from complex trees. We've done so in the past. So with that knowledge, we can start right into the demo. What will I show you in the demo? It's not a typical demo. Instead, what we did, we simulated a real project and ran through all the stages with my colleague Antje, which we will virtually meet here, recording all the steps. We choose a system where, as I said, we simulated a real project, a mini project. We choose a system where there's no connector right now, and we haven't done a migration project so far. So it was really a new project for us, and we did all the steps I described previously. We identified our internal Jive system and wanted to migrate marketing information from Jive and migrate it to Documentum. So everything you see here in the demo is real, and you will also see that it's quite straightforward and less complex than it seems at first sight to analyze the database. In fact, using the database connector, as I mentioned already, is quite a typical assessment we used for several systems. What's in the demo? So first, we analyze the database schema of the Jive system. Second, we configure the database connector to extract the documents. And third, we do a quick run through all the steps that are required in a migration center migration process. So it's also kind of a small introduction to Migration Center. And in addition, we showcase how to archive deleted documents to a file system or any long-term archive as you choose. And finally, we'll point out how to handle multiple versions in such a migration scenario, and we will migrate these multiple versions to a SharePoint system. So what you also see is that we have the option to migrate your legacy application into several target systems. So assuming you already know what you want to migrate, the first step is to analyze the database and identify the elements in the source application and identify them in the database, the reflecting elements. So having a quick look at Jive. Jive is a collaboration system organized into communities. You see here, the communities are called places. And within a place, people can collaborate, share content, tasks, organize polls. But today, we want to migrate documents from a marketing place. Here we are in the marketing place. As you can see, there are 16 elements currently, 15 documents, and 1 blog post. We'll meet this blog post later in the database, but for now, our objective is to migrate the documents. So we need to identify the documents, identify where the content is, migrate the PDF file, and also we want to migrate some additional metadata which is stored with the documents. So we is still running. So acknowledge it's 15 documents. So going into a document, you see the content. We want to migrate the content to the target system. We want to create a creation time modifier, this, so the basic metadata. So we proceed now identifying this in the database. Therefore, you can connect using any SQL tool. We use the SQL Server Management Studio. Connect, browse the tables in the database, and look. Basically, names are helpful, and look what's in there. Looking at the names. So here we find a table, blog posts. Yeah, it looks familiar. Boxworks, yes. Going back to Jive. Yeah, here's the blog post Boxworks. So you see it's reflected in the database. And just looking for the names of the tables, we've already identified our blog. Since we don't want to migrate the blog posts, let's proceed further, having a look at the names. Jive community. Here in the Jive community table, you see names. These names, here's the marketing. These names reflect the pulse places. Back to the database. And let's go on if we can find some documents here. The table D Jive documents. So some metadata, but nothing too familiar. Yeah, doc versions. Yeah, this looks better. Data sheet. So have a look back in Jive. Yeah, white paper. We can look for a white paper. Modify the query. Reorder by the title. Yeah, and here it is. Yeah, so we already found the documents records. So now browse further if we can find anything interesting. So probably we can find some users. Yeah, here we can find the users with username and an email address. This may be quite important for the migration later on, as we need to map the users from the source system to the target system. But probably there is a better way than having a look at the database itself. Maybe the schema is documented either by the vendor or documented in a community, or maybe you even know it because you created the application on your own. So in the case of Jive, we've found the schema documented in the community. Let's go to the Jive document, the documentation for the Jive document table. Here we can find quite interesting. There is a container type and a container ID. And these may indicate where the document is stored. And Googling a bit further, we find that there's a content type. Community is content type 14. Back to our database, you see that the marketing has community ID 2008. And then going back to the documents table, we see the container ID was 14. And then we identify the marketing place. Yeah, 2008, container type 14. And now putting this in our SQL statement. Container type 14, container ID 2008. This gives us 19 rows. 19 rows. And basically we had 15 documents. We'll come to that later on. 15 documents, 19 rows. It's a bit too much, but we'll clarify this later on. So what we found out now is that Jive Documents holds the information where a Jive document is stored. Still, we don't see the attributes. The attributes for any version, which can change from version to version. So let's yeah. Let's have a look at the internal doc ID 1077 and have a look at the versions table. And here we can find some metadata, the title, the creation date, the modification date for the specific document. So what you've seen till now is that it's quite straightforward getting information about your database, about your legacy ECM system, and putting this all together to configure the database scanner to extract the documents from Jive. So the next step is setting up the database connector. First of all, what we need is the connection information to the database. That's crucial. What we see here is everything is documented. It's a screenshot from the documentation of the database connector. So everything is, you have everything you need at hand. So what you see here, that apart from the connection information, it's very important to specify the query file. You've seen in the slides before the demo is that the SQL statement is specified in the XML file, and into the XML file we put the statement we just worked out, where we can find our objects. So this will be the statement to extract the objects from the database. Put it in here, and now we already see the second statement, and this query will extract the metadata for the objects. You can use any SQL function. You can use any SQL function that's supported by the database server. In this case, for making it look nicer. What we haven't done yet is specify the way how to retrieve the content. We retrieved all the objects. We retrieved some metadata information for the objects, but we still need to retrieve the content. And again, back to the documentation, you see that we can specify the path where the content is located. And we don't show it in this demo, but there's also the option that you retrieve content from a blob file. So in this case, Jive stores the content on a, in this case, we have the content on the file share, UNC share. We need to find out where we can retrieve it from. For this, providing the content path here, for this we need to do a little bit more. Googling. And in fact, again, it was quite straightforward finding the way to the content. But we just need to implement this in SQL. And inject it to the content path variable in the XML file. So now we have analyzed the database, found out where we can find the metadata, the objects in the content, and we've set up the database connector, especially the SQL statements that are required to retrieve the content. So now this brings us to a run through of Migration Center, running through the whole migration process. In this case, we already set up a scanner to scan the Jive repository. We see the properties, the connection parameters, the query file we just set up. And the only thing we need to do now is execute and run the scanner. So you can see the scan run. The result is 19 objects as we found in the database. Remember, it's only 15 documents. But we can also see the metadata, the title, and the state, and that's the clarification. There are 15 published and 4 deleted documents. We'll come to the deleted documents later. So the next step is that we need to set up a migration set. We already prepared one. We assign the scanner to the set, and now we can apply a filter to exclude all the deleted documents because we only want to migrate the published documents. Now there's only 15 assigned to this migration set. Next step is to set up some migration rules. We've already created some, and in addition, we have created, apart from the creation date, creator name, modifier, we've created a specific rule, just a subject where we defined a fixed value from Jive. So those are the transformation rules we need to execute. So the minimum we need to define for these migration rules is one rule for each attribute that at least needs to include the information which field of the source system or data source the value is mapped to. And as you can see here, there's only one rule, but this is quite a huge field. So what you can do here is really configure complex migration rules that can be quite a lengthy thing, but you can do it all very complex, but without any coding. What we still need to define, and that's where we are here right now, is we need to define or provide where the content location of the source document is. In this case, we will find it from the path we've set up. You remember the statement, the path variable. And here, that was too fast. So here under association, finally we need to define which transformation rule is associated to which attribute of the document type in the target system. And in this case, we create a DM document object in Documentum. So having set up these rules and associations should enable us to execute the transformation and validation. And as you can see there, transformation was executed and immediately stepped to the validation process, and we've validated 15 objects. So we've run the scan, we have set up the transformation, we have validated. The next step would be to import the validated documents to the target system. So we choose an importer, a Documentum importer. We assign the mix set, migration set to the importer, and we are ready to run. Takes a while. You see how it's counted, but now it's how it's counting. But now we've imported 15 documents to the target system. Let's verify this. Here you can see in the reports where the documents were imported to. And now we're changing to Documentum, finding the documents in Documentum. You see the documents are there. Metadata have been set. Content was transferred over. So it seems to have worked out. And also the extended properties, the subject from Jive, it's there. So to showcase some extended capabilities. Now you remember we had 15 documents, but we had 19 objects. Now we decided that we wanted to archive the remaining deleted 4 documents to a long-term archive. For this demo, we don't have a long-term archive here, so we migrated to the file system, showing you how we can migrate to several different target repositories. So it's quite easy to set up this new migration path. So we've already prepared a scanner. No, we have the scan run. We already did the scan run. Sorry. But we need to create another migration set. You remember 15 were in the first migration set, but we want to drill down the other four in another migration set. We already prepared this. What we need to do now is choose the scanner. From the scanner, 4 objects are still available. Those are the deleted ones. We choose these 4 objects. Go to the rules. Provide the path where we want to store the documents in the file system. And once again, execute the transformation. When the transformation is done, we move to the importer. Same thing in the importer. We have to assign the mix set to the importer. It's a mix set we have just run the transformation on and run it. And then let's go to the file system, and what you see here, the documents have been archived to the file system. Including metadata. Last thing I want to show you in the demo is how we can handle versions, because this is quite the typical case that we not only have a document with a single version and a single content file, but typically we have multiple versions and we want to handle all of the versions. For this showcase, we've chosen SharePoint to migrate the versions of. We've created one document in another place. It's an IT-Ausbildungsplan in the IT group place. Looking at the versions, there are 3 versions with metadata. Now again, we are back in the documentation. The documentation points out how we can set up the SQL to retrieve all the versions from the object, and in addition retrieve all the metadata from the versions. So what you see here, main, is the statement where we retrieve the object. Versions is the statement where we retrieve all versions for the main objects, and version metadata is the statement. And here we can use multiple version metadata statements. In this statement, we retrieve the metadata for all the version objects. Here we choose another query file. It's another query file. Again, run the scanner, retrieving this single document. And now we see that there are 3 objects retrieved, and you can see the level in the version tree reflecting the version number of the single version objects. Again, we have to assign the scanner to the migration set, select the objects, 3 objects, configure the transformation rules, and this was too fast. And here you can see that this is a configuration parameter is major version, meaning that each of the versions will be a major version, but there's also the option to migrate different version schemes, for example, major minor versions. So we run the transformation and validation. Once this is run, we assign the mixset to the importer, and we can run the importer. This is all going quite quick, and we can have a look into the SharePoint system if the document was, or the version series, the document with the version series was successfully imported to the SharePoint system. Having a look at the version history shows us all 3 versions were imported as major versions. For more information, have a look at our website. You will find white papers there. You can download a free trial copy. You can have a look at our reference and success stories and find more information about our migration services. And don't hesitate to contact us. So for further questions, you have the option to ask them now or contact me afterwards. Thanks.
Okay, thank you, Jens, for this great presentation and those insights with a live demo from Antje. So far, we don't have any questions. If you do have questions, just contact us through our dedicated website Jens mentioned before, migration-center.com. There's a contact form on there, and we are happy to get back to you as soon as possible. So thank you for attending. We hope to see you again soon in our upcoming webinars. And all there's left to say is, it's FME you love to work with. Thanks a lot, and bye-bye.